So again, hello everybody. Thank you for being here. It's really nice to have such an audience. Hopefully we'll expand upon this in future events. So yeah, as Santiago clearly pointed out, my name is Haritos Kavallos, and basically I'm going to talk to you guys today about what's called data warehousing. Okay, so it's no secret that today's society, business and computer science really go hand in hand. Okay, I mean, computers power businesses, and at the same time, business is an aspect that, as Stephen before mentioned, it's very prominent in engineering in different fields. So data warehousing has become important in the last several years because it's really helped to globalize a lot of very large corporations. Okay, so I focused mostly on Walmart, which is a company we're all familiar with, and just because Walmart tends to actually have the biggest public data warehouse in the world, so I thought there's some interesting statistics there. All right, so before people understand what a data warehouse is, it probably probably helps to understand what a database is. Okay, so really a database in the simplest terms is really just a collection of data. Okay, so you can think about it as a giant box you open up and you kind of throw a bunch of stuff in there, and at some point you want to interact with this data. So you might want to do what are called transactions. So you have transactional languages known as SQL, for relational databases, where you can actually write certain commands to either modify data that exists in your data warehouse and in your database, or to actually retrieve the contents. Okay, so these are the two different types of transactions you could have. And such a system that I'm describing is generally known as an OLTP system. Okay, OLTP being online transaction processing. So, I mean, if you haven't heard of databases before, then maybe that doesn't make much sense. So let's look at some real-world examples, right? So, for instance, first of all, I mean, I guess the biggest use of database these days has been in web-based systems. So, for instance, there's a lot of history students here, so I'm sure you've all used the Omnivox system, right? So the Omnivox system is a good example of a system that's supported by a database. You'll go onto some web page, you'll enter your username, you enter a password, and you'll have access to a bunch of information that's related to you. Okay, your grades, your courses, all that information exists on some server somewhere. All right, and the reason that information can be accessed is because of databases. So databases are really an important thing today. And I guess to tie in more to the Walmart example, cash registers, right? So you go to the local Walmart, you want to purchase something, all the cash registers that clients go through are tied into some sort of database system. So every time an item is scanned, the customer is informed the price. Every time you make a transaction, you buy something, the database has to be modified to keep control of inventory, right? So inventory is a big thing. Managers in stores need to know how often they need to replace the inventory, right? What the rate of turnover is. So these statistics can actually be extracted from database systems, and each local Walmart would obviously have its own system where it can keep track of its inventory. Okay, so that's what we call an OLTP system, right? So finally, let's look at how that compares to a data warehouse, all right? So a data warehouse is kind of different. Whereas an OLTP system is really used for everyday transactions, it's meant to be fast. There's usually a lot of different users interacting with the system, and usually the transactions are pretty simple. It's simple things like, okay, well, deduct this item from the inventory, or give you the price of this item. And of course, since there's multiple cash registers going on at any time, a lot of cashiers are interacting with the system. Okay, so it's a pretty often used system. It's used for daily data processing. Data warehousing is a little bit different. It's a little bit more complicated because a data warehousing really focuses on larger transactions. Okay, so it's not about simple things anymore. Now we're looking at larger, more complicated queries, which usually involve one or two people. So typically, corporations might have one or two people somewhere in corporate headquarters that will actually manage the data warehouse and interact with the system. And really, the purpose of a data warehouse in the end is to get historical data. So in a company, you have a bunch of top corporate managers that they want to know numbers, right? How well are we doing in Canada? How well are we doing in the States? Where are our losses? What can we do to make our sales improve, right? So all these questions can be answered with the help of a decision support system like a data warehouse. Okay, so like I said, this data warehouse can be queried, and you could generate specific reports that managers can then read and understand, and then use that to kind of make operational decisions based on data that exists. So really, it's just a decision-making system. So to get a little bit more technical, when we're designing these systems, right? So if any of you in computer science are familiar with this, there's a few steps involved. It's not as easy as saying, okay, well, I'm going to sit down, I'm going to create a database, and we're good to go. A database usually involves a lot of conceptual thinking. People have to sit down with the client, figure out the needs, and then go through a bunch of steps. And then at some point, you're going to get to a point where, for an OLTP system, you'll have what we call a relational model. The relational model is really just a graphical representation of a database. Okay, and you'll have different tables that each represent a certain set of data, and then each table will have some sort of relationship that's connected by special keys, right? So special references that we call primary keys. So this is what it would look like if you're designing an OLTP system. And what's important to gather from this really is that when you're designing the system, you go through a process called normalization. Okay, so normalization is the idea of cutting down redundancy. So in the database of this sort, you actually want to keep redundancy low. You don't want to have data that repeats itself, because if data repeats itself, then there's more chance that people might make mistakes in the data, right? So if someone's name should only appear once, not twice, because someone might make a spelling mistake somewhere. So the idea is design a system in such a way that redundancy is gone, and at the same time, integrity is kept in the sense that this system will work. So that's the OLTP system. And then in contrast, the data warehousing scheme is a little bit different. Okay, it looks the same, but for instance, you have two different types of tables in this case. You have what are called dimensions, which are those gray tables here for date, store, and product. And then we have a fact table in the middle. Now the fact table is actually the key table in such a system, because when people are writing transactions and they want to interact with the system, typically they would be querying this fact table, because the fact table has information like, for instance here, there's an attribute there called units sold. Okay, so like I said, managers want to know certain things. They want to know how much of a certain product was sold, how much money you made off that product, what are the profits. So the fact table is what's really going to have all that data in there for you when you query it. Okay, then the dimension tables, of course, offer support, because as you can see here, there's actually references to each of these dimensions. And I mean, this is a small-scale system. This isn't realistic of a real-life system, because real-life systems would typically have maybe 10 to 12 dimensions, and you always usually have one fact table. Okay, and this, of course, is called a star schema, because as you can imagine, if there's a lot of dimensions around here and they all connect to the fact table, it kind of resembles a star. All right, and there's variations. There's also snowflake schemas which extend the idea a little bit. But what's really important here, and what differs from an OLTP system, is that data warehousing involves denormalization. So as opposed to actually removing redundancy, you're actually keeping redundancy. Okay, so instead of having a bunch of little tables split apart, you're actually going to combine a lot of tables together that make sense to create bigger dimensions. Okay, so for instance, if you look at product, we have brand, and then we have product category. If this is an OLTP system, then brand and product category might be foreign keys to other tables. Okay, so OLTP systems tend to have more tables and tend to be normalized, whereas data warehousing kind of throws normalization out the window. And there's a reason for that I might have to explain. So let's look at how this works in real life. So let's assume that we're talking about Walmart Canada, and here we have the set of all Walmarts in Canada. So here I have created, but imagine it's the entire set of all Walmarts. Each Walmart, like I mentioned to you guys, will operate its own database. Each Walmart will actually have its own OLTP system where it will take care of daily transactions like purchases and keeping track of its inventory. and all that historical data related to each store. Then at some point in time, based on certain intervals that corporate will decide upon, each of these Walmarts will have their data extracted, processed a certain way, and then actually inserted into the data warehouse. And once that data is put into the data warehouse, now all the data from all the Walmarts in Canada is easily accessible by the people at the top, right, by management. And the idea is you have what are known as OLAP servers. So the data in the data warehouse, obviously, it's in a raw format. So obviously, people at the top have to be able to interact with the system without having to worry about the little nitty-gritty details, right? So managers at the top are typically not computer experts. They're not data warehousing experts. So when they're using the system, they want to have a nice graphical user interface that makes it life easier, right? So these servers will actually create those reports, and then the reports will be outputted to the front end. They'll be outputted to the terminals that managers will use to actually, print out their reports and generate them. So this is generally how it theoretically might work in a company like Walmart.